name is Nij, and this is the song and dance that led to the special theory of relativity. First up, the song. It's from Monty Python, it's the Galaxy song, and it goes a little bit like this. Just remember that you're standing on a planet that's evolving and revolving at 900 miles an hour. It's orbiting at 19 miles a second, so I was reckon the sun that is the source of all our power. The sun and you and me and all the stars that we can see are moving at 1,000,000 miles a day in an outer spiral arm at 40,000 miles an hour of a galaxy we call the Milky Way. Next up is the dance. This is the interference dance, and it tells us how we add two waves together. And we're all going to do it together. First move starts like this. Yeah, just like that. Perfect. Awesome. And it goes up and down. And here we have two waves, exactly like that. Here we have two waves, peaks lining up with the peaks, troughs lining up with troughs. That's called constructive interference and gives us the second move of our dance, which is a really big wave. Awesome. Alright, the next move is when we get one of those peaks and we line it up with a trough. Looks a bit like that. It's a bit tricky, you've got to get your hips into this one. It goes a bit like this. Awesome. When you add these two waves together, you get destructive interference, which is a wave that cancels. Give yourselves a round of applause. And those dance moves are what two guys, Mickelson and Morley, danced to the Galaxy song in 1887 to test whether the speed of light depends on our motion relative to it. Just like everything else we knew about in our universe at the time. The speed of sound, the speed of a bike, the speed of your dog. As you're walking your dog, it looks stationary relative to you. And here's what they did. They sent out two beams of light at 90 degrees to each other to bounce off mirrors to come back to a screen. And they arranged it such that at the middle of the screen, the two light waves had peaks lining up with troughs, which was destructive interference. Now the idea was, if light behaved like everything else we knew, as our speed changed in any of these directions, the troughs and peaks would start to line up with each other. And then see that interference pattern change. Now because of the Galaxy song, they expected it to vary wildly all of the time. But they looked in the morning, and they looked in midday as it span around their axis. And they looked in November, and they looked in May as it span around the sun. And they're still looking right now. And no one's ever seen that interference pattern change. And that crazy result is what led Einstein to think, hang on, maybe the speed of light really is constant. And maybe it's time and distance that are relative. And that's the result that led to E = mc² and the special theory